Okay, in section 2, topic 2.2, we're going to discuss nets. And nets are drawings of three-dimensional shapes that are put on a sheet of paper that's only two-dimensional. And let's start with example 1. We're going to draw a net that would form a cube. And you want to make sure that when you do draw one, you do have 6 squares, because a cube is made up of 6 squares. I think I'm going to show you one. We're just going to draw it. This is probably the easiest one to do. You just draw 4 squares connecting them. These are called the faces. The lateral faces would be these 4, and if I drew 2 squares to make 6 total on either side, if you were to cut this out and fold it up, it would create a cube. I found on the internet there are 11 different nets of cubes. Let me see if I can show it to you. This is kind of like the one we just drew, this first one here. It's got 2 on either side, but they're at the top. And if you look at these all have 4 that go down. Oops. They all have 4 that go down and then 2 on either side, because when you fold it up, these end up being the part of the faces on the sides, and these make the lateral faces. Here's another one. These are just versions of the straight line of 4 with 2 on either side. Now these down here, see if we can see them. Let me take the light away for a minute. See, they're a little bit different, but there are 11 different types of nets that are for cubes. And I do have a copy of this if you want to take a look at it. I may even show it to you if you come up and get some extra help. I can show you those. But those are the 11 different nets that you can draw to make a cube. Let's draw one that would not. That's one that would make a cube. Let me show you one that would not make a cube. If I were to do the same thing and put the 4 squares going down, and then I were to draw both of the 2 squares on the same side, think of folding this up. These 2 would overlap, and they would be on the same side, so it would not create a cube. Okay. I have some that are flat. If you want to, I can show you. We can fold them and I can show you how that works. I have several like that. Let's look at the next one. If this net was folded, below was folded along the dotted lines, what type of figure would be formed? And when you look at the shapes of a prism, the lateral faces, which are these 4 that are going this way, these are called the lateral faces because they're around the sides. This one right here and this one right here are called the bases, and the bases are what you use to actually name your three-dimensional shape. And anytime they talk about one of the lines, that's called an edge, and the vertices are the corners. Why don't we label that? Like this right here would be called an edge, and any corner on here, I'll just put a little dot, is when they ask for the vertices of a prism, they're talking about the vertices. Now the faces are all the shapes that create the three-dimensional figure. So this one's called a rectangular prism. Because it's made up of 2 bases that are rectangles. And we're going to go to one now that's a triangular prism. If you look at this example on the next page, it's a triangular prism, and it has, the reason it is because of the bases. The bases are these 2 shapes that are parallel to each other that are the same, and these are triangles. If you look at the 3 lateral faces, they look like 3 rectangles that go around, or maybe even squares. So if you were to draw a net, you want to connect the edges of those rectangles, and then you do want to make sure your bases are on either side, So if I were to draw the triangle base up here, I would have to put it right here. Another one, I could draw the same thing with 3 rectangles. These are the lateral faces, and I could alternate. I could put one of the bases here and then one over here. It would still fold up to create a triangular prism. Like I said, I have a lot of these prisms and pyramids that are in shapes that you can actually fold. So if you want to, let me let you look at those. Alright, on example 4, this is more of a visual exercise where you are going to take the solid that's drawn as a net and draw it from 2 different perspectives. Now, this might be a little bit harder to do. Just remember that when it skips and it has an empty space here, these are going to be parallel to each other. So for instance, if I were to take and draw the sun up on the top square, I'm not doing this very well, but anyway, just think of this as on this top square. Because this skips here and goes to the star would be below it. So let's see if I can draw a star. Okay, so that's because those are parallel to each other. Now, because this moon is right next on the face, right next to the sun, and it's a crescent shape with it's kind of facing the sun, it's going to be folded down and go right here on the cube, on the right side of the cube. Now this solid circle right here, it's going to kind of take up my picture, but it would be on this front one right here. So it's kind of going to go right here. That's one perspective. Okay, let's flip this upside down, and if we put the star, we started with the star, I'm sorry, the sun shape on the bottom. Again, the one that's parallel to it would be the star. So it's like they flipped. This star now would be on the top of this cube. And this time, if we're going to draw the perspective of the side with the moon, since it's going to go, let me think, this moon shape looks like it would still be on the side, but this time it would face upward. It's almost like this whole thing's just turned around. This would come around, instead of facing down, it would face up, because it's almost like we've turned this and we've flipped it upside down. So instead of this dark circle right here being in the front part of this cube, it would be in the back part, on this back. You might even write that. This one's on the back, and this little circle's on the front. And sometimes on a standardized test, they'll ask you to take a shape and think of it in a 2-dimensional form, folded up into a 3-dimensional perspective. Those are kind of tricky, but you can look at that example. Okay, I think that's it for this one.